guys, welcome back to my channel. Today, it's DIY time. I'm going to repurpose this old box remote from my flyaway drone and hope we can control something else. So let's get started. We're going to use this Arduino Uno and NRF24l01 modules. First thing is to disassemble this remote. 1, 2, 3. This is the main board of the remote. I already removed the old transmitter module. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 buttons and 2 analog joysticks. So right now I am removing all the connections of the buttons and the joysticks. We don't want the old circuit to interfere with our new connections. So the 2 buttons here, disconnected. On the other side, also disconnected. The buttons in the bottom side, also disconnected. And for the first joystick, disconnected. And for the second joystick, also disconnected. At this point, I'm checking the connection if it's already disconnected, and also checking the components if it's still working. Then it's time for some soldering. Grab the wire, solder head, and solder iron. At this point, I am connecting all the common grounds of the buttons and the joysticks and the VCC of the joysticks in this schematic. For the transmitter, I chose to use this boosted version of the NRF24l01 module to test the antenna. And I already soldered this electrolytic capacitor here. It's used for smoothing the supply. And I soldered also the wires for the connections. Twisting the wire reduces the interference of the other wirings, so it's recommended. And then to put the transmitter here. Just like so. Oops, on the other side. No, the other side. So the NRF24l01 module needs a 3.3 volts power supply. So we need a linear voltage regulator to convert a 5 volt supply of the Arduino to 3.3 volt for the module. Now we're going to wire the data signals of the NRF24l01 modules into our Arduino, but except the power supply. Follow this schematic. So it uses the pin 13 for the SLK, pin 12 for the MISO, pin 11 for the MOSI. It is necessary for the 3 pins to be connected to the right pins, but the SCN and the CE pin 9 and 10 can be placed in other pins. Now I'm routing the input and the output wires of our linear voltage regulator. Solder the power supply from the NRF24 got a problem. How can I program the Arduino? Well, at first, I can program it before assembling all the parts. But reprogramming it will require dismantling the cover every time. So I use some old USB cable, solder some thin wires, and connect it directly to the pins of the Arduino USB port. Now we need to power up the NRF24l01 modules by putting the regulator from the ground pin and the 5V pin of the Arduino Uno. I'm gonna try to power the Arduino if it will power on the NRF24l01, and it does. Now I'm going to connect the all common grounds of the joysticks and the buttons and the VCC to the 5V pins and the ground pin of the Arduino. I'm using a 7.4V battery from 18650 batteries and this connector to make it removable from the remote. So I'm going to solder the negative supply directly to the negative of the barrel jack. And then the positive part will be cut off by the built-in switch on the remote. Switch, let's see the turn on, and turn on. The transmitter is turned on, and the Arduino is also turned on. It's time for more soldering. So I'm connecting all the digital pins on the Arduino to the buttons and the analog pins to the joysticks. Follow this schematic. So the schematic is for what you prepared, where you want to connect the buttons, but mine goes something like this. So after that tons of soldering, we will build the remote in one piece again and try to do some testing. So for the transmitter code, so here is the libraries, SPI libraries, the NRF24l01 libraries, .h, But for this, we need to define our inputs. So I name the buttons left left, left right, right left, right, down right left, down right, down left and right. So this is the pin outputs for 5, 4, 3, 2, 6, 7 and 8. So the RF24 radio 9 and 8, that is the pin that we are connected. And constant byte address is the 0001. This is the address that it needs to be similar from the transmitter and receivers, so they can communicate with each other. So this is the data that we are transferring. So this is a byte. So AX is this is the joystick 1, AX. AY, the second joystick is the BX and the BY. For the buttons 2, 3, 4, 5, 6, 7, 8. So the buttons in the physical remote is 10, but we only use the 8 pins of the digital pins of the Arduino because the 9 and 10 is already used, and the 11, 12, 13. So I don't want to use the analog inputs for these digital pins, digital buttons rather. So for the setup, we had serial begins if you want to check the inputs of your remote. So this one is the default of the transmit the library. So this one is low, I set it to max. So the difference is the range and the consumption of the power on the power, but it's not that far. Then we need to set up our pin. Pin mode is all in pull up because we are connecting it to ground when we click the remote. So in default it is in pull up. Then we will set the data of the AX. This will be the default values. So if we are not pressing any buttons or not moving the joystick, it will receive these 127 datas and 1s for the buttons. So why 27? Because when the analog joystick is resting, the middle value is 127. So from 0 to 255, that's the byte. So from the void loop, we will going to map the AX value because we are reading on the analog signal from 0 to 1023, and we will converting it to 0 to 255. So we're doing it for the 4 potentiometer of the analog joysticks, and for the digital pins we are going to read the digital signals from the buttons, and then we will write all the data in the package and send it to our receiver, and that's all. So here is our receiver's code. So this constant byte 0001. So this is the same address as our transmitter. So we are sending the same structure. Then this is the default again. And then sa void loop, we are checking if we are connected to the transmitter, and we read the data in the package that it's sending. So we use this the last time value. We set last time received, we get the value of millis. Then for the current time, we get again the value of the millis. So when the current time minus the last received time is more than 1 second, it means that we are disconnected. So we run this reset data setup. So I will show you that later. So for the output, we're only using the serial monitor for checking the output if we are receiving the data. So I print out the data as you see here. So for the void reset data, this is when we are disconnected to the remote. So this is for the safety of our machines. So let's say we are controlling a drone, then we suddenly lose the connection, then all the data will be reset as 0 or whatever you want to put in this as the reset data value. So the drone will fall down or not continue flying without controls. So let's try this. I hook up it to the another Arduino with NRF24l01 modules inserted.
So let's monitor it. So sorry. Upload. I didn't check the ports. Okay, it's done uploading. Let's check the serial number. Okay. Oh, sorry. So this is the default value. All is 0 when my remote is turned off. The buttons are all in ones. When I turn on the remote, and this is the value. So this is the AX. When I turn the remote, it goes to power, the X, and the Y axis of the joystick. Going down, going up, going down. So for the B axis, for the second joystick B, the X axis going up, oops, so Y going up, going down, and the X axis going down, going up. So for the buttons, I will press the button 1 and press 0, button 2, button 3, button 4, button 5, button 6, and button 7. So that's all. Thank you for watching. For the next video, I will show you how to use this receiver to control something else.